Hello, everybody. We'd like to welcome you to Cobots and Coffee, hosted by Doosan Robotics. And the topic for this month is a cobot the right solution for your business? With that, I would like to introduce Alex Lee, General Manager of Doosan Robotics Americas. Alex, take it away.
Yes, hello, good afternoon, everybody. Thank you for joining us for Cobots and Coffee. I also want to thank Manan Banerjee from Cross Automation for being our guest today to talk about is a Cobot solution right for you? So cheers, Manan. Hope you have your coffee. Hope everybody has their coffee. All right.
Never go a day without it.
So today's topic, it's kind of interesting because it's not like cobots have not been around for some time now. It's well over 10 years when the first cobot was introduced to the market space, but it's kind of like microwave to me, like a microwave. I'm still trying to figure out how to use it and finding new ways to use it. So I think with cobots, it's kind of the same. It's been in the marketplace, but and I've seen some uses for it. I'm starting to see some kind of interesting and creative uses for cobots now. But there's still a lot of question out there about whether or not a cobot is really the right solution for some of the applications people are thinking about, and then maybe they just don't know where to best utilize this. So that's really what we're going to talk about. I just want to give Manan an opportunity to introduce himself as well, and maybe you could tell him about your background.
Sure. So I work for Cross Automation, which is one of the 7 divisions of Cross Company. Cross Company's been around for 70 years or so now as a value-added distributor of industrial automation components. The automation group has 3 main focuses. One is linear motion control, so servos, steppers, actuators, rotaries, that kind of thing. Pneumatics, which is using compressed air to do things. There's a lot more to it than that, but in a nutshell. And then robotics, which is the newest division of the automation division. And we started out with collaborative robots in 2013. So I am the robotics product manager for the innovation team, which is the group that does integration within the automation group.
Mm-hmm. 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 Great.
Yep.
Well, thank you so much, for coming on board, and hopefully you can help us kind of put some answers to these questions. So why don't we start by just saying, what, in your opinion, what is a cobot?
Sure. So pretty much everyone knows, I think, what a traditional, we call them industrial robots, which is a little bit of a misnomer because collaborative robots can be very much industrial in the way they're applied. But when you think of an industrial, yeah, thank you, Stephanie. When you think of an industrial robot, there's always guarding around it, right? More or less always, unless you're absolutely sure there's not going to be a person anywhere near the robot, you're going to have some guarding. That's because an industrial robot, if you tell it to go from point A to point B, it's going to go to point B. And if you're in the way, you're going to have a bad time. It's going to try to go right through you. Obviously, that robot can, it's capable of picking up probably a few 100 pounds and moving it very, very fast. So you do not want to be in the way of that robot. You don't want to be within arm's length of it, right? So where the guarding becomes important is you take the overall work envelope of an industrial robot. You say, where is everywhere that this robot can reach in space? And then you take a certain number of feet past that and you put guarding up around it, right? So industrial robots always going to have guarding, and that guarding is going to stretch out the footprint of wherever you deploy that robot. Contrasted with a collaborative robot, they're designed from the ground up. It's not designed to output more than a certain amount of force and power with its movements, right? So if you tell it to go from point A to point B, that robot inherently is designed, if it collides with something on the way, it's going to stop. Now, important point to note, a lot of people think that means, hey, if I just touch the robot gently, it's going to stop. Not quite. First of all, you wouldn't want it to, you could probably make it that sensitive. In almost no case would you want it to be that sensitive. just because you want it to be a little more robust than that. If you make it literally touch sensitive, it's just going to be detecting collisions all the time. But fundamentally, a cobot can detect a collision and stop, which makes it safer, right? One of the important things to note about a collaborative robot, yes, the robot itself, collision detecting, force and power limited, that's certainly a big piece of the safety puzzle. That's great. That doesn't necessarily mean you don't need guarding, right? You may not need guarding. With an industrial robot, you will have to have guarding. With a cobot, you may not, depending on the application. My favorite example is if you put a chainsaw on the end of the robot, it doesn't really matter if the robot can detect a collision. Your application is not collaborative, which is at the end of the day what really matters when you're deploying a cobot. But yeah, in the picture you see here, the cobot's picking up a part. There's not a flamethrower or a grinder on the end of it. In an application like that, you might have a person there by the conveyor belt doing this, dull and repetitive task day in and day out. If your application isn't particularly hazardous, you may not need guarding, and it's so much easier to deploy a cobot there and automate that task than an industrial robot. It's not nearly as drop-in. It's not nearly as much of a drop-in replacement for human capability.
So Manan, I think you touched on a really important point. I mean, obviously, the whole idea of collaborative robotics is the safety. But are there also other things that make a cobot truly different, unique, or maybe a scenario where a cobot may be more advantageous in terms of implementation, maybe in the areas of the ease of use, or maybe for some people they might be more interested in and they've probably heard that cobots are less expensive than industrial robots too. What are your thoughts on that?
Yeah, so just straight out of the box, a cobot might be less expensive than an industrial robot. It really kind of depends. That's such a broad way to compare them. At the end of the day, I think what is a more important thing to keep in mind is cost of ownership and cost of deployment. Cobots, especially over the last couple of years, because they're a new thing, right? They've been more or less designed from the ground up. A lot of cobot manufacturers took the opportunity, including Doosan, shameless plug for all of us, took the opportunity to look at, okay, we have the robot here. It's a technological marvel, right? Let's look at how you actually program it. What's the experience like for the user? And they took that opportunity to make a much more intuitive programming interface. If you look at an industrial robot, the teach pendant, I'm not saying anything bad about them, but the reality is the teach pendant probably has 50 years worth of, legacy stuff on it, right? So if you look at an industrial robot teach pendant, most of the time it's going to be kind of overwhelming. Cobots typically have been designed to make the user interface much more intuitive and user-friendly, meaning that the learning curve to learn how to program one is greatly reduced. Yes, you still do, it's beneficial to have some programming experience. It's beneficial to have, kind of a technical mindset to predict what the robot's going to do as you're programming it. But for the most part, one of the big benefits that we've seen from a deployment standpoint is, number one, easier programming is faster deployment. So, this investment starts paying for itself much sooner. Number two, the skill requirement to program a cobot tends to be much, much lower than an industrial robot. You don't necessarily need an engineer or a team of engineers or, an integration company all the time to help you deploy a robot. Your technician that's running the process can be trained to deploy a robot to that process or a cobot to that process. So yeah, ease of use and implementation, certainly a big draw of cobots.
Wow, that's awesome. So I think we understand, you combine safety with the ease of use. Sounds like rapid deployment is a key advantage of cobots. So which leads to my next question for you, which is, based on your experience, what are some of the most successful cobot applications that you have seen yourself?
Sure. So as far as specific application types, palletizing, like you see here, the process of picking up a box and putting it on a pallet, the product, like the workpiece, the tooling, the speeds at which it's typically done, especially if there's a person doing it right now, right? It doesn't leave a whole lot of room for there to be a hazardous tool or some kind of unsafe speed. Yes, it can happen, but in general, palletizing lends itself very well to cobot automation. Machine tending is another big one. I would say that's probably the first one that people think of. You know, I have a CNC machine, I have a person loading parts in and out of it. They're not really adding value while they're sitting there waiting for the machine to churn and taking parts in and out, right? That tends to be another, you know, well-proven, well-developed one that we see a ton of. Case packing can be one depending on the product. The caveat there is depending on what you're packing in the case, your end of arm tooling might take some thought and research and trial and error. But case packing is certainly a big one. Path following is another big one, and not just because of the labor savings, right? So yeah, welding, like we see here, welding, dispensing, any kind of path-based inspection, like, you know, laying down a weld bead and then checking the quality of it, following it with a line scanner, right? Those tend to be really good applications for cobots because, of course, there's the labor savings. You're taking a person out of that process, but anything where you have to maintain where your quality is impacted by the speed and the accuracy of your path, even over 1 8-hour shift, a robot is going to be way more consistent at both of those things. So in that one, it's kind of a double whammy. Like, okay, you've saved some labor in not having a person do that process, but you're also increasing your quality with no, you know, just automatically, just as a function of automating it. So those are some of the key ones, I guess.
So I have an interesting question regarding applications. What have you run into any interesting applications? Everything we've just mentioned, it sounds like has been primarily in the industrial space. You've got welding, pick and place in the packaging and palletizing. Anything that you have come across over the so many years you've been working with cobots that strikes you as interesting?
Yeah, so there's two. We had a broadcasting facility put a camera on the end of a cobot and use it to film their broadcast.
Nice.
That was pretty cool. The other one, we had a company that was making, and these were both deployed and running, right? Not just proof of concepts. The other one was they had a module. I'm not going to go into too much detail, but they had a module that had like a card reader with like a keypad and a touch screen and everything. And they wanted to do quality testing on those. So what they used the cobot for was they set up a little test stand with stations, like a dummy credit card, a dummy stylus for the touchscreen, a dummy pointer. And to do their regressive testing, they would stream, you know, any combination of test protocols. Hey, go to the keypad, hit this combination, go to the touchscreen, touch it here, do this, you know, jimmy the credit card in there like someone who's having trouble with it. They would stream commands from like across the world and have the robot carry them out in their test facility here. So that was a really cool one.
That's awesome. That's interesting. Yeah. I think that speaks volumes about the flexibility of this technology too. You know, it lends itself very well for applications that maybe traditionally an industrial robot, like you said at the beginning of this call, goes point A to point B and it's programmed that way. This one is flexible enough that it can take commands streaming, safe enough that it's around humans to do something like that too. That's pretty awesome. Yeah. So moving on, I guess, you know, for our audience here, I guess the thing that I think a lot of people are going to be curious about is, you know, what would you say is like the key to a successful implementation? What kind of things should people know beforehand jumping into a cobot application? and what do you think is key to the successful implementation for these types of applications?
Yeah. In my experience, one of the major things is to know your process. Know it inside and out. Know every single detail, every single hiccup that happens as part of normal operation with that process. If the customer does the homework first, or we help them do that homework first, the overall project tends to go without too many surprises. And honestly, what I was saying before about being able to not requiring a team of engineers to program a robot, there's a tie-in to that, right? If you can have your person who's doing the process day in and day out, if you can have them program the robot, that's your source of knowledge about the whole process, right? Because a lot of times you'll have an engineer design a process. Excuse me. Nothing against engineers. I've been an engineer. We know all the specifications of the process, right? The person out on the floor doing the process knows that every 30 minutes you have to take a rubber mallet and hit the machine right here. Otherwise, it's going to jam up. And things like that, like there's always going to be gremlins, as we call them, hidden in any particular project. Knowing all those up front sets you up for success. And so if you get the people involved early on that know the practical details of your process, you have a much higher likelihood of success.
Yeah, so that's an interesting response. I think to look at a project and understanding your process. So when we go and define that a little bit further, I guess my question is, you mentioned a couple things early on, like repetitive processes and things like that. It seems like collaborative robot implementation is probably better suited for things that are going to be doing these repetitive type tasks and so on. So when we talk about, I guess to dive a little bit deeper into know your process, are you saying that there's some applications that just aren't well suited for this, or are there other, if you were going to weigh out where to use the Cobot in your plant or your application, which one would you suggest we look at first as a quick way to success?
As a quick way to success, the repetitive process is almost always going to win. The most repetitive process with the least amount of variation is inherently easier to implement a robot on. Now, that being said, one of the big benefits of not requiring guarding on a Cobot necessarily is that you can consider it a tool to move around to wherever you need it, right? So we say repetitive with the least amount of variation, right? One of the windows of opportunity that's been opened up is for job shops or places with low volume, high mix. So I've got lines A, B, and C. I have huge labor problems. They're doing palletizing, and it's a very repetitive process. No one wants to do it, right? Human beings like to apply ourselves. Most of us, I won't say there's nobody, but most people like to apply their problem solving capabilities to more complex problems than where do I put this next box, right? But if I have 3 lines and I'm not even running all of them every day, it's very hard to justify the investment into this big industrial robot cell that is fixed. Once I put it inside guarding, it's fixed. I could move it. I'm not going to move it. No one ever moves an industrial robot cell from day to day. But what you can do with a collaborative robot, once you've taken all that out, is, hey, today I'm running line A the whole day. Tomorrow I'm not running line A, I'm running line B. A collaborative robot opens up the possibilities of moving the robot where your demands are for the day. So yes, repetitive tasks with little variation are always going to be easier, but with a collaborative robots, the possibilities are now much wider.
Awesome. So, for anybody who's interested, and maybe there's some people that are absolutely new to cobots, for that matter, new to automation as a whole, and this could actually kind of frighten them to delve into something like this. It's really an unknown. And we make it sound like it's easy, it's flexible, it's safe, all these things. What do you suggest is probably the best way to approach their first implementation?
Sure. So, identifying what it is that you're trying to do, right? What's my problem? I have a labor shortage. I can't carry out this process. Number two, is it repetitive? Like there's like the technical qualification and and like the economic qualification, I guess, right? The best way to approach it, I think, is to reach out. You can do a ton of research. You can order a robot arm very easily. That's honestly the easy part. Figuring out how to deploy it, most people are going to need some kind of guidance. And that's where I'd like to think Cross has a lot to offer. We've, like I said, since 2013, we've put a ton of robot arms into factories or production processes, not even just factories, right? Smaller machine shops. Almost always the process starts out with, hey, this is what I'm trying to do. Cross, like one or more of our people will go out and take a look at, hey, what are you trying to automate? Okay, this is, these are the challenges. These are the mitigating factors. This is what kind of robot you're going to want. It can seem almost overwhelming, but having a team of experts that's been doing it for a while certainly helps. Like having that another set of eyes on your process, specifically to automate it. Yeah, I mean, we like to consider ourselves, whether you're buying just an arm or you want some kind of help with it, programming assistance, designing a tool, or doing a full turnkey integration. We like to consider ourselves as an extension of our customers' engineering teams. So shameless plug, that is something I'd recommend doing, is to reach out and have someone come in and evaluate.
Awesome. Thanks, Manan. So we are coming close to the end of our time. So I do want to quickly summarize and give you a chance to kind of put your last word in. But in quick summary, it sounds like cobots in general, in comparison to industrial robots, they're certainly safer. It sounds like they're definitely easier to use and quicker to deploy. These types of automation, and perhaps even more flexible based on the application you talked about, the credit card reader, and just all sorts of different things you can do with the cobot itself in terms of repurposing them. Typical applications that we've seen so far has been in palletizing, machine tending, pick and place, welding, inspection, case packing, things like that. But it seems like there's this whole nother frontier that the cobot is going to be just a great utilization of automation into maybe food and beverage, doing cooking, cleaning type tasks and things like that. So with that, are there and of course, in terms of implementation, it really would benefit anybody who's new to this to get some advice, consultation, and also maybe support from system integrators, just like Cross Automation, to provide probably expert advice and then expert implementation, so that your first use of a cobot will become extremely successful. With that, did you have any final words you wanna leave us with, or?
I'll continue with the shameless plugs. Visit crossco.com, see what we can offer for you. We also have a much broader ranging podcast called Innovating the Industrial World. It has episodes from each of our, many business divisions: mobile, hydraulics, electrification, process control. It's worth checking out.
Awesome. Thanks, man. I really appreciate your time. And now I'll hand it over to Stephanie. I think, we'll be happy to answer some questions with the remaining time that we've got. So, Stephanie?
Yeah. So we do have up at the top of your screen, guys, you'll notice that there's a Q&A box. You're welcome to submit questions in there. We do have a couple of them. I also wanted to let everybody know, if you'd like a link to Innovating the Industrial World, please just reach out to me via email and I can link you to that, so you can get in touch with Cross Company to see what they're doing, which are some really amazing things right now. So our first question right now is from Ken. Ken asks, the safety standards for a cobot are obviously not the same as a standard robotic application. What are the differences?
Awesome. So I guess that's a question for me. So I'm going to try and make this not a super rambling response, right? The safety standards for collaborative robots are described under ISO 10218-1, which is for the manufacturer of collaborative robots, and ISO 10218-2, which is for anyone integrating a collaborative robot. So the complete answer to your question can be found in one of those. Now, when we're talking about implementation of a collaborative robot, let's say we're not trying to use guarding, right? Like what does it take to not have to use guarding? Well, you can use an area scanner that detects, intrusion into a specific zone, and that'll trigger like a reduced mode in the robot, or a safety rated stop. The main difference is that an interlock doesn't need to be broken to enter a robot work area necessarily. It totally depends on your application. And it's always super important to do a thorough risk assessment of your application, meaning, hey, what are the hazards I'm going to see? How frequent are they? How severe are they if any harm is caused, and how easy is it to mitigate? The robot being able to detect a collision is a big piece of the puzzle. Obviously doesn't replace, just the robot being collaborative doesn't, remove the need for people to design safe work cells. But things like, speed and separation monitoring, how far away can your light curtains be from the robot? If you need to use light curtains and you're moving at a pretty good clip and someone breaks it, there are some differences there. I'll be honest and say I'm not the guy to have a detailed conversation with about safety standards. Our engineers get much more into that. But ISO 10218-2 will tell you what kind of guidelines are there for designing or for deploying a collaborative robot. I hope that answers the question.
Our next question is from Matt. Do you think AI is the answer in solving the variability of Cobot applications?
In the long term, probably. In the short term, there are people that are doing some work on it that are being pretty successful at it. Here's the thing with AI, right? You have to spend the time to train it. So it's much better at dealing, like if you're looking at images from a camera or something, right? And AI has much more flexibility in like detecting like good or bad parts if that's what you're doing, right? But you can't ignore the time that it takes to set up and train an AI system like that. I think just putting a camera on a robot and hooking it up to some kind of neural network and just letting it go is not quite that feasible. Yeah, so that's what I'll say about that without overreaching.
Not today, but I would have to say that I think Matt's question is very valid. I think in the future, we've been talking about the repetitive work and things like that these cobots are designed to do right now. They obviously are capable of doing a lot more if you attach AI and are able to really implement a unique solution like that. You're really going to be able to tackle these variable type applications. So I think there is a future for that. It's just I agree with you. I don't think it's today. I don't think it's something that is a viable solution that's readily available today. Yeah.
Wonderful. Our next question is from Philip. What other hardware is required to implement a cobot in an industrial environment? PLC, industrial PC, controller, etc.
That's a great question. So that was kind of a list of more controls type stuff. It kind of depends on your application. Most robot controllers, including the Doosan, will have some amount of I/O built into the controller, right? And a lot of applications, the robot teach pendant works just fine as an HMI. Okay. Depending on your application, if you need an HMI, yeah, get an HMI. If you need additional I/O, there's ways to expand that without a PLC. Like you could use a Modbus interface and just do a straight I/O expansion. If you need some other logic controller, yeah, you'd need a PLC. your end of arm tool and your part presentation are probably going to be the two biggest pieces of hardware that you'll need on just about every robot deployment. And honestly, if I'm being totally honest, a lot of work and thought is going to go into that part presentation and the tooling. Like 60-70% of the projects that we've done, like the total effort, 60 to 70% of that is how does the robot know where the parts are? So that's going to be a big part of the additional hardware that you're going to need for the project, for a deployment is tooling and part presentation. Whether that's a conveyor or a nested part or just a flat table with a camera, it's going to take some effort. So that's the big stuff. Mm-hmm. If you're machine tending, you're probably going to need a CNC machine or some kind of machine to tend. So that's a pretty big one, I'd say.
Great.
Does that answer the question?
I think so. Yeah. Our next question is from Jay. Jay says currently 25 kilogram payload is the maximum capacity. Do you think a higher payload is required for Cobot applications?
Mm-hmm. Did you want me to answer that one?
It doesn't matter to me. You can. I have an answer too.
Yeah, I'll give you the answer from the manufacturer's standpoint. The reason why, here at Doosan we created the 25 kg maximum payload robots was mainly to address the fact that the Cobot was designed specifically to work alongside humans, and there really is a task that a human right now is required to do that requires them to lift more than 25 kg. Now, that being said, could there be a higher payload Cobot, and are there applications for that? Absolutely. Cobots, just in the sheer nature of it being safe, like we've been talking about, and easy to deploy, they're going to quickly become a very quick go-to technology, go-to piece of automation. And having a higher payload is definitely going to be beneficial. So will you see potentially maybe even Doosan Robotics building a higher payload Cobot? It's very possible. But keep in mind, the original intent of collaborative robotics was really so that we can work alongside of a human. And at a certain point, when the robot is lifting, 100-pound load, it's no longer even safe for a human to be around, just in case the product gets dropped. So that's where we're going to have to draw the line. We may call it something else. It may have a new name. It may not be called a Cobot anymore. Because it's not collaborating with humans, but it's a safer version of an industrial robot that has extreme payloads. So watch out for that. It might be coming soon.
Great. We have one more question from Bob. Bob asks, does Doosan make their own vision equipment cameras, or must you use a third party like Cognex?
Yeah, I think we do have products, but it's not it's a 2D camera. I think most of these applications that we're getting involved in require probably a little bit more sophistication. So a 3D vision camera is probably more suitable for those types of applications. I would highly recommend working with third party, and obviously we partner with these companies. So we'd be happy to recommend. Also, this is a great question for Manan, because you probably implemented cameras before and worked with Doosan Robotics. Do you have any suggestions in terms of vision applications that you've done with Doosan, and what would you recommend?
Yeah, vision can be tricky. Cognex is certainly one of the big names. You'll almost certainly find a camera that'll do what you want it to do. It kind of depends on what you're trying to do, what your capability is, whether you're using an integrator, how demanding is your application, do you want to program it yourself? I know there's several third-party manufacturers that make vision systems that may not be super duper, highly capable, but they're very easy to plug and play. I say plug and play. It's almost plug and play, but it's very user friendly. It's easy to get it up and running. If what you're doing with the robot is, say, picking up a part from a table and loading it in a CNC machine. With vision, it's kind of like, hey, you can get as complicated as you want. Doosan has the Mate ecosystem, which is third-party products and software that are known to work well with the Doosan robot. That's on the website. I'd highly recommend checking that out. Ultimately, every vision application kind of needs its own technical qualification process. It has a lot to do with the parts you're picking up. Is there a window near where you're putting the robot, right? That was probably more information than you were looking for strictly, but it's important to know.
Awesome. Thank you.
Great. I believe those are all the questions, which is perfect timing because we are just about out of time. If anybody does have any questions, oh wait, Chance has a question. We'll get this one in real fast. How accurate are the cobots when moving in and out of different jobs/cells?
Might need some clarification on that. What do you mean how accurate when you're moving in and out of cells? Can you clarify?
Chance, if you can type that in the chat.
Yeah. So if you're talking about repeatability, the Doosan, so imagine, do I have a pen on me? No. Imagine you have a pointer on the end of your robot, right? Like just a straight pointer. The tip of that point would be what we call the tool center point, the TCP, right? The Doosan robots can put that point anywhere in space. If you do it repeatedly, it'll be within 50 microns in a little bubble. So certainly, unless your application's super precise, that's more repeatability than you would need. But I'm still interested in some clarification on that question, because that's the easy answer, right? Refer to the spec. Here's the repeatability.
Mm-hmm.
We may have to catch up with Chance to get further clarification on that. Oh wait, here it is. If you had one robot programmed with different EOT in different jobs, moving from one job one day to another job another day.
That's a fantastic question. So repeatability still applies, right? If you're moving it around from cell to cell, the robot's repeatability is important. How you locate that robot when you're moving it from cell to cell also becomes important. Now, that being said, there are ways around it, right? And that's kind of where programming experience and things like that come in. If you have, let's say you have a table. Your application is, I have a table and I just want to go to a bunch of different points. If I program all of those points on the table as an absolute position in space relative to the robot, if I move the robot away and then move it back, I'm probably going to be off by some amount, because now you're totally dependent on how accurately are you placing the robot every time you move it, right? But if you program it so that all your points on the table are offset from one corner of the table, even if your robot placement isn't super accurate, all you need to reteach to the robot is that one point, and then all your other points are offset from that. So you're good to go. It kind of depends. We've mechanically located robots to the machine and not bothered with reprogramming points. We've to build experience, you got to burn yourself a couple of times, right? We've programmed applications before where we had 400 waypoints just programmed as absolute points in space, and then the customer wanted to change, and the very first thing we did was program it all to a relative feature. That made it much easier. So Chance, I hope that answers your question. It also depends on how accurately you model your end of arm tool to the robot and tell it where that tool center point and the center of gravity and things like that are. So there's a lot that goes into it, but it's how you deploy it that has a big effect on that, for sure.
Awesome. That was great.
Okay, well, we are just about out of time. So we want to thank everybody for joining us today. Manan, thank you so much for lending us your knowledge and experience and expertise. We truly value Cross Company and some of the really cool things that they do. If anybody would like to get in touch with Cross Company, please reach out to me. I can connect you to them. If you have any questions about Doosan Robotics and what we do, I'm going to throw my information up here. You are welcome to reach out to me via email. And we hope to see you all next time for Cobots and Coffee.
Yeah. Thank you guys for having me. It's been a pleasure.
Thank you, everybody. Have a great day.